Hi everyone, I'm Maddie, and today I'm going to be talking about testing for week 6 for CS1501. So just a little overview about what we're going to talk about today. We're going to go through validation versus verification, different types of testing, unit testing and TDD. We're going to talk about information needed for our demo and your activity, and then there will be separate videos going through different demos of testing frameworks for the different languages. And then I'll talk more about your activity. So validation is, did we build this thing correctly? Does the software do exactly what the customer asked for? And verification is, did we build the thing right? Does the software do what was intended or implement the specification that was given to it? So for example, if you go to a restaurant and you order a blueberry pancake, you first see the pancake and you see that there's blueberries on it, it looks like a pancake, that's verification. But you won't actually get to validation until you taste the pancake and you realize that it's a blueberry pancake, and that is exactly what you had asked for. Most of the testing we're going to talk about today is verification testing, but validation is just as important, and you'll see this throughout the industry. So different types of testing. So unit testing we'll talk about in a little bit. Integration testing is when you have different modules and they all work together, so you need to test that they work correctly together. And then system testing includes stress testing. So when you put a lot of load onto your program, you see how it reacts and if it still works correctly. And then performance testing is testing how your program performs on different inputs, and if it performs the same way or how different it performs. And then usability testing is basically testing how user-friendly your program is. Acceptance testing is testing that's used to make sure that your program does exactly what the customer had asked for. So this is more of validation. Most of the other stuff is verification, but this is really validation. And then there's beta testing, which is when you have a sample or a group of people come to test your program and see that, or your program or software, and see how they use it to make sure that they know how to use your program even though they've never used it before. And then regression testing is if you make a small change, so if you fixed a bug or you made an enhancement in your code to make sure that little change did not break your code and that your test still passes. So what is unit testing in TDD? Unit testing is when you test an individual module that you created to make sure that it's working correctly. And then TDD is a software testing approach where you make a little bit of code, just enough to pass your test, and then you refactor your program's code. And then you go back to the test and you run it again. And if it fails, you update the test to make sure that it keeps working with the way that the class has been refactored, and then you do that until it passes, and then you go back, and it's this repetitive cycle until you get your program where you want it to be. And unit testing is used for these tests usually. So here are the steps that you should probably go through when creating a unit test. You should just take a method and consider how you would know if you wrote it the correct way. Like consider how would you know that you wrote it the right way? And so you can do this before writing the code or maybe during writing the code. And this forces you to really understand what you're building. And then you can run the test for yourself, and you can test it along with other unit tests and make sure that they all pass together. And if they don't pass together, there's probably something wrong with your program. And so you need to go back and look at your program before moving forward. And then once your test passed and you feel like your program is in the place that you want it to be, then you've successfully passed. So what makes up a unit test? Usually there's a precondition or setup that sets up the test in a way, or sets up the variables in the test in a way that you want before you're about to test. And the description is basically what the test will do. An expected result is what should the system state be after test. So this is something you already know before doing the test. So if you had a program that took an array and rotated it, then you would know that the output should be that rotated array for any input that you decide to put in. So you know that that's the expected output, regardless of what the method does. And then the actual results would be would be what actually happened when you ran your code through that method. And then you would compare those results to see if the test had succeeded or not. And then tear down basically undoes everything that setup does. And it resets the testing environment back to where it was, so then you can create more tests. Or you can end it. So here's an example of some tests. So let's say we have a program where you roll a pair of dice. And so for test one, it just has a player roll the dice and they move one. And then the second test is basically the same thing. So these are valid tests, but are these the best tests that they could be? Or is this better? So the precondition is that the game's in test mode, there's a game board already loaded, and there's a game in progress. And there's two players, and the player one rolls a 3. And so this kind of sets up the whole test, and and we expect that the player rolls, since the player rolled 3 on the dice, then that means that they're gonna move to space 3. And then the actual results would be what actually happened when it was ran through that dice program. And then for the second test, the precondition is that test one ran successfully. So then if a player two rolls the same dice, then the same thing that happened for player one should happen for player two. So this is definitely a valid test to see that once there's already a player on the playboard, that you're able to run the test with another player. So why do we do unit testing at all? We need to know that each module works, especially if you're working on a larger scale project. But honestly, the bottom line is that it gives you confidence that your code does exactly what you think it does. But it doesn't do, what it doesn't do is that it doesn't tell you if it's the right thing that the customer had asked for. That's more of acceptance testing, more of what we talked about earlier with validation. And it also doesn't tell you if all system components work together well and correctly. So this is not integration testing or performance testing. So here's the bigger picture. Testing will be important for you in internships and throughout your career in CS. And after this week, hopefully you'll know a little bit more about the different types of testing and be able to create and write your own unit tests. And this process will always be automated, probably any company that you work for. Once you create a test, and then before you're going to be able to push your code, you're actually going to see all the other tests that other people had also created on your team, and those will be run against your program as well. And your test will also be run against the program which you had added your code to. So it's important that you test your program completely before adding to larger scale projects, because we don't want something little that you did to affect the overall goal, especially if you're working on a project that has a lot of customers. So the demos for this week will be, we'll have a video for C++, which for Catch2 is the testing framework. We'll have JUnit for Java, and we'll have PyTest for Python. And so a little bit more about your activity is we'll have a Google Doc under week 6 materials on the course website. And so you can apply what you learned from the lecture and demos to write your own test. And then you'll also be able to see how testing can help make effective programs and how maybe you can find some bugs. So the submission format is that you'll make a copy of the week 6 activity, which is a Google Doc. You'll write your answers to the questions provided. Then after answering all these questions, you'll download the file as a PDF, and then you'll rename it as specified below, and then you'll submit it to Colab by October 9th at 11:59 p.m. So good luck on this week's assignment, and this is all I have for testing. See you later.